For centuries, humanity believed the moon was simple, a silent, stable companion floating above our heads. One face, one surface, one story, the same sky every night, the same craters staring back at us, the same calm illusion of permanence. But everything changed the moment we finally saw what lies on the other side. Because what exists there does not match what we were told, and it does not behave the way it should. The far side of the moon is not normal, and it is breaking everything we expected. For thousands of years, no human being ever saw the far side of the moon. Not once. Because of a precise gravitational lock, the moon rotates at the exact same rate it orbits Earth. That means it always shows us the same face. Forever, the other side remained hidden behind perfect cosmic timing. An entire half of a world locked in darkness, untouched by human eyes, for all of civilization's existence. Ancient cultures imagined monsters, gods, eyes watching from the darkness. The moon controlled tides, seasons, fertility, madness. People feared it, worshipped it, studied it, but they never saw its other face. Until machines finally went where human eyes never could. In 1959, the Soviet probe Luna 3 transmitted the first grainy images of the far side of the moon. The photos were distorted, blurred, incomplete, but even through the visual noise, something felt wrong. The surface did not resemble the familiar near side at all. It looked brutal, violent, scarred. That moment marked the beginning of one of the most unsettling discoveries in planetary science. As technology advanced, orbiters mapped the moon in higher and higher resolution. What once looked like a blurry wound became a brutal landscape of towering crater walls, fractured crust, and massive impact scars overlapping each other without order. The far side of the moon is dominated by chaos. Meanwhile, the side facing Earth tells a completely different story. Vast dark plains called Maria, formed by ancient lava flows, cover much of its surface. The terrain is smoother, flatter, more stable, less violently marked by impacts. The moon is not symmetrical. Half of it looks calm. Half of it looks like it barely survived. Scientists expected the moon to be roughly balanced because it formed from the same cloud of material after a single massive impact in Earth's early history. And yet, one half of the moon is structurally different at nearly every measurable level. The crust on the far side is dramatically thicker. In some regions, more than 50% thicker than the near side. That alone defies early formation models. A thicker crust prevents magma from easily rising to the surface, which explains why the far side lacks the dark lava plains seen on the Earth-facing side. But that only deepens the mystery. Why would molten material flood one side of the moon and not the other? Why would one hemisphere cool faster than the other? What force created this planetary imbalance and then froze it into place for billions of years? For decades, scientists tried to explain it with gravitational interaction from Earth. The theory was simple. While the moon was still molten, Earth's gravity pulled heavier material toward the near side, thinning its crust and allowing lava to flood upward. Meanwhile, the far side cooled faster, thickening its crust before magma could escape. It sounded elegant, but the numbers never fully matched. Computer models failed to recreate anything close to the extreme asymmetry we observe today. Something else had to be involved. Then came the gravity maps. Modern lunar satellites began measuring tiny changes in the moon's gravitational field with extraordinary precision. What they discovered was deeply unsettling. Beneath the surface lie enormous concentrations of dense material known as mascons. These dense regions distort gravity so powerfully that they can alter the path of spacecraft in orbit. And the distribution of these mascons is wildly uneven. Some are associated with giant impact basins on the near side. Others appear partially compensated by strange internal distortions on the far side. It is as if the moon's interior was torn, bent, crushed, and then locked into a permanently distorted state. The moon is not gravitationally quiet. And then there is the heat. For a long time, scientists believed the moon was completely geologically dead. A frozen relic of early solar system history. No core activity, no internal motion, no future changes, but deeper measurements challenged that assumption. Beneath certain regions, scientists found signs of residual heat. Weak, hidden, but real. Even today, the moon is not entirely cold inside. Traces of ancient volcanic systems still linger in the crust, especially near regions tied to gravitational anomalies. And once again, the far side refuses to behave like the rest of the moon. It has few signs of large-scale volcanic flooding, yet its interior shows chemical and thermal inconsistencies that remain unexplained. The moon is not uniform, and it gets stranger. When astronauts placed seismometers on the moon during the Apollo missions, they expected to record small vibrations from meteorite impacts. What they discovered instead was something no one expected. The moon rings. Moonquakes behave very differently from earthquakes. On Earth, seismic waves lose energy quickly as they are absorbed by water, sediment, and layered rock. But the moon has none of that. Vibrations continue for long periods, echoing through its interior like sound inside a hollow shell. Some moonquakes last over an hour. The moon behaves like a cracked bell, and the far side produces seismic behavior that does not perfectly match the near side. Again, not normal. Then there is the question of magnetism. Today, the moon has no global magnetic field. It cannot shield itself from cosmic radiation. It is fully exposed to the violence of space. But ancient lunar rocks returned by astronauts tell a different story. Billions of years ago, the moon had a powerful magnetic field. A magnetic field requires a molten, moving core, which means the moon was once far more active than we ever imagined. At some point, that magnetic field collapsed. The dynamo died, the moon lost its shield, and the remnants of that ancient field vary across the surface, including unexplained irregularities on the far side. Yet again, its hidden half refuses to match the rest. At the center of all this mystery lies one of the most violent scars in the entire solar system, the South Pole Aitken Basin. A colossal impact crater over 2,400 kilometers wide, so large it would cover entire continents on Earth. The impact that formed it released energy beyond comprehension. Many scientists believe this single event alone nearly shattered the moon. It may have fractured the interior to such a degree that magma flow, crust formation, and even the moon's gravitational alignment were permanently altered. If that is true, then the moon we see today is not simply the product of a single formation event. It is the survivor of multiple catastrophes. And catastrophe leaves instability. The moon's far side is also exposed to something Earth protects the near side from: relentless radiation. Without Earth's magnetic shield, the far side absorbs some of the most intense cosmic radiation in the solar system. Over billions of years, that exposure alters chemistry, weakens structures, and reshapes surface material at the atomic level. It is a side that has endured punishment without relief. Which brings us to the most unsettling truth of all. The moon is not a static object. Its interior cooled unevenly, its surface solidified asymmetrically, its gravity bent into irregular patterns, its magnetic field vanished unevenly, and its most violent impacts reshaped only one half of its body. This is not equilibrium, this is a frozen imbalance. Today, the moon controls tides on Earth. It stabilizes the tilt of our planet. It regulates long-term climate patterns. It slows Earth's rotation. Without the moon, Earth would oscillate wildly. Seasons would become extreme, weather patterns would collapse into chaos over geological time, which means the moon is not just a decoration in the sky. It is a structural stabilizer of life. Any long-term instability in the moon affects Earth. Always. That does not mean the moon is about to break apart, but it does mean we are orbiting a body that is far more complex, scarred, and unpredictable than early science ever imagined. The far side is not hiding aliens. It is hiding the fossil record of unimaginable violence. It is hiding the visible aftermath of impacts that tore through a world. It is hiding geological trauma frozen in stone. The moon did not simply form. It survived, and survival leaves permanent damage. When people ask why the far side of the moon looks so different, the true answer is deeply unsettling. Because it tells us that natural worlds are not formed gently. They are forged through disaster. Broken through collisions, bent through gravity, and sometimes left permanently unstable. We expected symmetry, we found imbalance. We expected simplicity, we found contradiction. We expected a dead rock, we found structural memory of ancient catastrophe still written into the crust. This is why the far side of the moon breaks everything we expected. Because it proves that even the sky above us is shaped by violence we barely understand. That the nearest celestial body to Earth is not calm. It only looks calm. The scars are on the other side, and they are deeper than we ever imagined. The moon you see every night is only half the truth. The other half is still hidden in shadow, and it is not normal.